Hello everyone, here the question says the de Broglie wavelength of a particle of kinetic energy k. So of kinetic energy k is going to be lambda. The de Broglie wavelength is going to be lambda for kinetic energy k. What will be the wavelength of the particle if the kinetic energy becomes k by 4? Now the de Broglie wavelength. So according to the de Broglie wavelength, lambda is said to be the de Broglie wavelength, which is equal to h by momentum. Okay, h is the Planck's constant. We know that Planck's constant is equal to, the Planck's constant is going to be equal to 6.63 into 10 power minus 34. I think it is going to be S E is equal to h mu. This is going to be mu can be written as second joules second, joules, not joules per second, joules second. Okay, this is going to be the Planck's constant. Okay, so momentum, so we can able to change momentum into the kinetic energy. So to convert it, first of all I'm going to do here is, so kinetic energy k, I will be mentioning kinetic energy k is equal to of mv square, right? Of mv square, mass velocity square, right? So multiplying and dividing with m and dividing with m in this equation, we get kinetic energy, which is kinetic energy is equal to m square v square by 2m. Okay, this can be written as 2m into kinetic energy is equal to mass into velocity. So I'm just writing this as mv whole square, mv whole square in the above equation. Okay, in the above equation. So just this is separate. Okay, after this I'm going to do here, right, as 2m into k can be equal to momentum square. Mv is said to be momentum. Okay, then the value of momentum is going to be, momentum is equal to whole root of, taking square root on both sides, 2 m is the mass, k is the kinetic energy as here. Okay, so this is the thing. So I'm just substituting this momentum right here, and then we get, so lambda is equal to Planck's constant h by this thing, root of 2 into mass into kinetic energy. From this I'm just saying that, okay, this is said to be constant right here. So de Broglie wavelength, let us consider this is 2, root 2 is always said to be constant, and the mass is said to be constant. The finally the equation can be written as lambda is inversely proportional to the root of kinetic energy. Okay, this is said to be the de Broglie wavelength. This is going to be used right here. So this is the relation between lambda, that is wavelength, de Broglie wavelength, and the kinetic energy relations is this. So using this relation I'm just doing, solving the, finally we got this is lambda is inversely proportional to the root of the kinetic energy Ke means kinetic energy. Okay, in the question situation number 1 is going to be lambda 1, and situation number 2 is going to be the lambda 2. Okay, so as per the question, lambda 1 is going to be lambda itself according to the question. So I'll be underlining that in the question itself. I am just underlining. So de Broglie wavelength of the particle of kinetic energy K is going to be lambda, right? Okay, understood. So lambda 1 is going to be lambda itself, and the kinetic energy at the first situation ke, I will be writing as ke, kinetic energy at the first situation. Okay, suddenly what happened to the mouse point, I don't know. Kinetic energy is going to be equal to Yes, as per the question, at the first situation, kinetic energy is K. Okay, then KE1. I'm just KE1. The first situation, kinetic energy is said to be K. And at second situation, this is the first situation and the second situation. Second situation, so the wavelength is not given. We have to find what is the wavelength need to be find in the second situation. So lambda 2 is need to be find. So here lambda 2 is equal to the question mark. We have to find this thing. So I'm moving to the previous page, and let's look at if its kinetic energy becomes k by 4. K by 4. What is the second situation? In the second situation, that is kinetic energy in the second situation, Ke to kinetic energy in the second situation can be written as K by 4. Okay, using these two values, we are going to solve this question, and this kinetic energy is inversely proportional to the square of lambda. And continuing the equation, is lambda is inversely proportional to the root of kinetic energy. And now lambda 1, okay, since it is a direct inversely proportional, lambda 1 by lambda 2 is going to be equal to root of kinetic energy 2, kinetic energy 2 divided by root of kinetic energy 1. Okay, this is the important thing, you must note it down here. So and I am going to substitute the values in this equation. Okay, in this equation, so lambda 1 is said to be lambda, and lambda 2 is going to be yet to be find. I will be saying it as x. I have to find this x value. Okay, lambda 2 need to be finded. Okay, kinetic energy 1, so I will be taking its whole root of kinetic energy 2 is going to be k by 4. K by 4. Okay, here kinetic energy 1 is going to be k. Okay, now this k get cancelled, so it is going to be equal to root of 1 by root of 4. Yes, understood, which is going to be equal to 1 by 2. Okay, so from this whole equation, so don't see the pathways, so final value is equal to 1 by 2. So lambda by x is equal to 1 by 2. Lambda by x is equal to 1 by 2, right? So 2 lambda is equal to the x. X is a thing which we have to find. 2 lambda is the answer for this question, where it is option B is the correct answer for this question, that is 2 lambda. Thank you.